Hi guys, this is Dr. Cyril Benedict. Welcome back to my YouTube channel PhD Made Easy by Cyril. Hope you are all doing good and started reading. Now that we have seen the introduction of epidemiology, let us see tools of measurement in epidemiology. Because you know how we measure certain things with an instrument. For example, you measure a distance by a ruler. Like that, to measure disease and certain other characteristics or health related events, you need certain tools. Let us see those tools in epidemiology today. So before that, let us see a short concept. Okay, this concept can be asked as a part of an essay or a short note. Let us quickly revise it. It is called as principles of epidemiology. There are four principles: exact observation, correct interpretation, rational explanation, and scientific construction. Let us see these principles of epidemiology with an example. Okay, imagine there is this COVID-19 and you see high fatality rate. That is, more people are dying who are elderly and who are having other comorbid diseases. Okay, this is the scenario. So what is exact observation? It is accurate and precise observation of what is happening. So you precisely observe and see that yes, the death rate is more in COVID among people who are elderly. In that too, people who are having other comorbid diseases, other uncontrolled comorbid diseases, are dying more often than other elders and other age groups. So you observe this accurately and you interpret it accurately. So this forms the first two principles of epidemiology. Next, what is rational explanation? We have to give a logical reasoning for what is happening. What could be the logical reasoning here? See, people who are elderly are already having a weakened immune system or weakened immune response, and people who are elderly with other comorbid diseases, their immune status will be even further degraded. That is why any disease like this, an assault, causes these people to die more often. That is the logical explanation, that is the rational explanation. Finally, what is scientific construction? You finally try to give a scientific outline or a picture to what is happening. In this case, what is the scientific outline or a conclusion that you can give? You try to tell that elderly people, if they get COVID-19 disease, if they are having other comorbidities, and if those comorbidities are uncontrolled, there is a higher chance that these people might succumb to the disease, that they might die to the disease. This is the scientific construction. And there is one another way to look into it. Remember the classification of epidemiological studies? We can try to relate it here. The first step, exact observation, is usually done by an descriptive epidemiological study. The next, correct interpretation and rational explanation. Usually these kind of conclusions come after an analytical epidemiology and like doing an analytical study, cross-sectional, case control or cohort. Finally, scientific construction is usually done by conducting an experimental epidemiology. Thank you. So let us see the tools of measurement in epidemiology. How do we measure, or with what tools we measure the disease or a characteristics in an epidemiological study? There are three. They are rates, ratios and proportion. Let us start with rates. Rate, the definition goes like this, okay? A rate is a frequency of a disease or a characteristic expressed per unit size of the population or a group in which it is being measured. I'll give you the definition here. So there are four things to remember in a rate. Okay, four tenets to remember in a rate. The first is the numerator. The numerator is the population who are getting affected by the disease. The denominator or reference population is the population at risk of experiencing the event. Okay, it is the denominator from which the cases occur, try to occur. Next is a specific timeline, a timeline for the event to occur, and finally a multiplier. Okay, so let us see an example of incidence of ECC among children aged 3 to 6 years. So I am doing this study for a period of 2 years. That is the timeline. Okay, next is the numerator. Here the numerator goes like this: number of new cases of ECC among children. Next, the denominator. Denominator is the total number of children in that particular area between the ages 3 to 6. And finally, I have used the 100 as a multiplier. So let us put the numbers. For example, there are 5 children who are experiencing early childhood care is among 100 children. Okay, so 100 is the denominator, that is the reference population, the total number of children between 3 to 6 years who are at risk of experiencing the event, that is the denominator. 5 is the number of new cases of ECC happening in that 2-year interval, so 5 forms the numerator. The timeline is 2 years. The timeline is usually not present inside the formulae. Next is the multiplier. So the answer goes like this. It is 0.05 into 100. That is 5 per 100. Okay. So you can use either 100 or 1000 here. Okay. If you use 100, you should be telling 5 per 100. If you put 1000 here, the formula will, the answer will change, right? It will be like 50 per 1000. If you want to express it per 100, you multiply by 100. If you want to express per 1000, per million, you multiply it accordingly. That is the multiplier. And remember, in a rate, numerator is part of a denominator. In a rate, numerator is a part of the denominator, which means this numerator, this number of children, this 5 actually came from this 100 only. Okay, this 5 people, this 5 children initially was part of the 100 children who were at risk of experiencing the event. Various examples for rates are rates for birth, death and fertility rate. Next, ratio. A ratio is a tool of measurement. It is an expression for comparison of two quantities in which a numerator in a ratio is not a part of the denominator. Remember, in rate, numerator was a part of denominator, whereas in ratio, numerator is not a part of denominator. Let us take an example for a class where there are 10 students and 3 of them are boys and 7 of them are girls. So how to express this as a ratio? We can express this as male is to female ratio. Okay, so we can write it as 3 is to 7. Okay, so 3 denotes boys and 7 denotes girls. Some other example is what about a ratio in prosthodontics? Okay, so here if you write 3 is to 7, 3 does not form a part of 7. So numerator is not a part of the denominator in ratio. The last tool of measurement is proportion. Proportion is again an expression, whereas numerator is a part of denominator and proportions are usually expressed as percentages. We can see the same example expressed as proportion. The same example, 10 students, 3 boys and 7 girls. Let us say the proportion of boys in the class or the proportion of girls in the class. To say the proportion of boys in the class, you should tell as 3 boys out of 10 students. Okay, this can be expressed as 30%. Remember, I told proportion is usually expressed in percentage. So 30% of the class is boys and 7 out of 10 are girls. So 7 by 10, that is 70% are girls. So in a rate, numerator is a part of denominator. In a ratio, numerator is not a part of denominator. Whereas again in proportion, numerator is a part of denominator. And one extra cut is proportion is usually expressed as percentage. Thank you. Okay then. Hope this topic was helpful to you. Keep in touch for more videos and lectures. And start reading. Remember, it's not the perfect timing. It's about the first step. Happy learning. Thank you.